Hello viewers, this is a presentation and demo of washing machine simulation project developed as a part of embedded system internship. I am Prajwal Sangde, student of 4th year electronics and telecommunication of College Sri Sant Gajanan Maharaj College of Engineering, Shega. Here is the introduction. The washing machine has significantly impacted modern society by reducing the physical effort required for laundry tasks. Advancement in technology, particularly in embedded systems, have led to a diverse range of washing machine models with additional features. Its washing machine serves as crucial appliances for effortlessly washing various types of clothing. It offers functionalities like washing, spinning, rinsing, uh, such type of automatic functions. These functions we need to add in our project. For project of embedded system, we need to learn C programming. Hence, first first of all, in the internship, we learned C programming. In C programming, in C programming, we learned about various types of data representation, integrated number, and data types. Also, there are multiple conditional construct we uh, we had we had learned. In the embedded system domains, where power efficiency is crucial, C stands out for its optimization capabilities, particularly in memory usage through pointers. Conditional constructs that we learn are like single iteration, multiple iterations, etc. If, else if, switch case are the single iterations, where while, do while, for are multiple iteration. Continue and break are the unconditional ones. Learned from embedded C. What you have learned from embedded C? We have learned from embedded C that are operators, operates on its operands, return a value. Also array. Array is a collection of data of same type. Pointer. Pointer. Pointer means parameter passing mechanism in function by passing the reference. Then function. Function function is nothing but pass by value or pass by reference. Then strings. Strings are contiguous sequence of characters, easily stored in ASCII models, ASCII and its extensions. Storage class: auto, register, static local, static global, and extents, etc. Now, embedded system. What is meant by embedded system? Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. An embedded system is a microcontroller or microprocessor based system which is designed to perform a specific task. Its purpose is to control the device and to allow a user to interact with it. It consists of a microcontroller with onboard memory, a power supply, and communication ports for transmitting data to other devices. Types of embedded system. There are mainly two types of embedded system based on performance and functional requirements and based on performance of the microcontroller. Performance and functional based on requirements are further classified into four types: real-time, standalone, networked, and mobile. Real-time embedded system deals with the real-time situations. Standalone embedded system is the single embedded system. Networked embedded system is nothing but the network of multiple embedded system. Mobile embedded system: the embedded system which can be moved from one place to another is called as mobile embedded system. Here is the general block diagram of embedded system. General block diagram of embedded system consists of central part microcontroller. Here are various sensors, sensor conditioning, output interfaces, actuator, indicators, etc. Why we select microcontroller? A microcontroller is a single chip integrated circuit functions as a compact computer within an electronic system. Its MOS-based design incorporates a microprocessor, memory, and associated circuits, simplifying system control. Programmable for specific tasks, it efficiently manages inputs and direct signals within the device, streamlining functionality and reducing design complexity in embedded system. Where microprocessor contain arithmetic, logic, and control circuitry required to perform the function of computer CPU. We need to connect peripherals externally so it makes circuit bulky. For these reasons, we choose microcontroller over microprocessor. Components required for the project. The project is based on the PIC16F877A microcontroller and the component required are given below. Here are some hardware components like CLCD, LED, keypad, interrupts, timer, buzzer, and fan, and microcontroller PIC16F877A itself. Software we are using are MPLab, X8 compiler, PiximLab, etc. MPLab IDE we use for writing a code and editing uh, and for uh, compiling for etc purposes. And compiling the code we use X8 compiler. And lastly, PiximLab software we use to simulate our project. PiximLab software is useful for simulating the project we have done. Microcontroller PIC16F877A. PIC16F877A is a 40-pin microcontroller designed using RISC architecture, manufactured by Microchip, and it is used in embedded project. PIC16F877A has 5 ports on it, starting from port A to port E. It has 3 timers, 2 of which are 8 bits timers while one is of 16-bit. Here is the pin diagram of PIC16 F877A given aside. PIC16 F877A features 256 bytes of EEPROM data memory self-programming, a LCD, 2 comparators, 8 channels of 10-bit analog to digital converter to capture compare PWM function. The synchronous serial port can be configured as either 3-wire serial peripheral interface or the 2-wire integrated. Keypad. Keypad is a input device. In matrix keypad, we need to configure row as output and column as input. The switch activates when pressed and then turns off when released. Keypads are used to give input by the user in binary format. They consist of push button. There is a metal plate and terminal. Spurious pulse detection while pressing releasing the tactile switch is called as bouncing effect. Switches can be triggered in two different ways. Level triggered. Level triggered level triggered activate switch activated when voltage is one high level, and in edge triggered switch activated when level of voltage is suddenly changed. They s- Next, interfaces of LED. Simplest device used in most on the embedded application as feedback works just like diode. LEDs are connected to port B and port D. Port is port is a peripheral and we need to know how to access and address each peripheral. From the section of port B, it is clear that there is one more register associated with the name TRISB. TRISB is register very important for I/O configuration. Next, data processing in CLCD. CLCD or dot matrix liquid crystal display can interface with 4 or 8-bit microcontrollers. It's include VSS, VDD, contrast control, register, read enable, read write enable, and data lines. Addressing involves toggling of register select, toggling register select for selecting addresses and is initializing. In 16 is to 4 LCD, addressing is based on rows and columns. Data processed by two data processed in CLCD by two methods that is that are delay method and poll D7 method. In poll D7 method, we want to continuously monitor D7. In data lines, we are providing read write enable is equal to 1 to write to read and read write enable 0 to write. In read write pin is permanently grounded, that means only write a data. In CLCD, D0 to D7 are connected to port D and register select and enable pin are connected to port E. The enable pin signals the LCD about the start of data transmission from the microcontroller. Timers. What is timers? Timer is nothing but the simple binary counter that can be configured to count clock pulses. It can be either internal or external. Once it reaches the max value, it will roll back to 0, setting up an overflow flag and generates the interrupt if enabled. PIC16 AP77A has three independent timers: timer 0, timer 1 and timer 2. Out of which timer 0 and timer 2 are 8-bit timers while timer 1 is 16-bit timer. Interrupt. An interrupt is a communication process which causes the processor to stop its current task and handle interrupting sources. Sources of interrupt are external or internal. Internal vector table. Internal vector table is a data structure that associates a list of interrupt handlers with a list of interrupt requests in a table of interrupt vectors. Interrupt service routine (ISR). What is meant by ISR? ISR is a software routine that hardware involves in response to an interrupt. ISR examines an interrupt and determines how to handle it and executes the handling and then returns a logical interrupt value. Then buzzer and fan. Buzzer and fan are output devices gives feedback. Output devices. Buzzer. We all know buzzer is a device which makes sounds when the output is given. To turn on buzzer, we need to configure RC1 port is equal to 1 and for turning off the buzzer RC1 is equal to 0. Data direction register for buzzer is TRISC1 which should be 0 for output and TRISC1 is equal to 1 for input. Fan. To turn on the fan, we need to configure RC2 is equal to 1 and for turn off RC2 is equal to 0. Data direction register for fan is TRISC2 which should be 0 for output and 1 for input. Software used in the project. MATLAB IDE. MATLAB IDE is a pre-integrated toolset for development of embedded application on microchips, PIC and DSPIC microcontrollers. MATLAB software MPLAB's IDE we use for writing code. Then X8 compiler. X8 is a C compiler from microchip for 8-bit PICs and both programs run on Windows, macOS and Linux also. Then PiximLab software. PiximLab is a real-time emulate of development boards with integrated MPLAB GDB debugger for code editing and debugging. The same tools used for real board should be used with PiximLab such as MPLABX or Arduino IDE. Project requirements. Here are the some requirements that we need to do in our project. As soon as we power on the device, we want simulator to show a message like powering on the washing machine. After powering on, the simulator should show all the washing modes. Simulator also contain matrix keypad and with the help of its keys user will able to choose respective modes. In this particular design, we concluded pause button that will pause the time count and will turn off the device until it's released. After completing the event, time up message will be displayed on the CLCD. Then we need to we need to show demo. Mm, Here we are in PiximLab software for the project demo. First of all, we need to load our hex file. Here I am loading hex file. Here the hex file is loaded, and in the CLCD screen we press screen shows the press key 5 to power on the washing machine. Here are the switches, that means keys. Here is key 1, key 2, key 3, key 4, key 5 and key 6. Here I press key 5. Hence after pressing key 5, the CLCD shows power on washing machine. Then the washing program screen shows on CLCD. With the help of switch 4, we we can scroll down the washing program menu. When we click once switch 4, then the washing program menu scroll down, and after long pressing the same switch 4, we select we can select any program. Here I select daily. Here I long pressing switch 4. It takes some here. After some time, we CLCD screen shows water level screen. Here we can do same by pressing switch 4 at once. We can scroll down the water level menu, and long pressing we can select. Here we are long press and select auto. Then the screen shows press switch 5 to start and switch 6 to stop. Here I start by pressing switch 5. Here the screen shows, hey, as you can see, fan is moving, means our washing machine get started. The function is washing and timer is reducing. Here switch by pressing switch 1, it shows door is open, please close the door, and buzzer will also get long. Uh, Function. First function is wash, then rinse, and then spin. Wash is 46% of total time, then rinse is 12% of total time, and remaining is spin. Sorry, rinse is 42% and remaining 12% is spin. Here the program is completed, fan is stop and buzzer will ring. After that, the uh, our demo is completed and we have returned to wash program screen. Then now I show you our program. Here is our program. Here source files in which all the source mains c.c files are stored. clc.c, digital keypad main.c, and here are the header files. Here our main.c program. This part of the program is to show the first screen of the washing machine, that is press key 5 to power on washing machine. Then this part is for start stop switch 5 or switch 6, and this is a switch case statements for selecting different types of functions like washing program, water level program, start stop screen, etc. Now I show the uh, in its washing machine definition file. Here an array of the various types of wash program we created in the name of washing program, like daily, heavy, that we have seen on screen, and water level array also created for the functions. For wash program, here is the sorry here is the code for the various functions like wash, rinse, and spin. Here we use Here is the switch case statement for how much time the function should be wash and rinse and then spin for various wash program functions. Here is the main.h header files. In this file, we have created macros for all the macros required for all our functions. And digital keypad files, we have also created some macros for switch 1, switch 2, switch 3, switch 4, and switch 6. Hence, here, this is our code. Then, conclusion. The washing machine simulation project completed during internship helped me to understand the working of automated washing machine system and improved my skills in embedded system and logic implementation. It provided hands-on experience with simulation tools like MPLAB IDE, PiximLab, and enhanced my skills. Overall, it was a valuable and practical learning experience. Thank you. Thank you, EMERTXE, for providing the internship. Thank you.